All right, this is lesson 6.4, properties of rhombuses, rectangles, and squares. You will learn how to define and classify special kinds of parallelograms and how to use the properties of diagonals of rhombuses and rectangles. Go ahead and do the review here quick. You can check back the answers. You should try this part before I give you the answers. Try and decide whether the statement is always, sometimes, or never. Pause right now if you want to do that. All right, so a couple of special parallelograms. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And a square is a parallelogram with 4 congruent sides and 4 right angles. So we're going to write the words rectangles, rhombuses, and squares in this Venn diagram. I'll put rectangles here. And I'll put rhombuses over here. And a square is both a rectangle and a rhombus, so that goes in the middle. All right. Problem 1, classifying. Is parallelogram FG, HJ, a rhombus, a rectangle, or a square? Well, it's a parallelogram to begin with, so there's a lot of things we know about parallelograms. One thing we know are opposite angles are congruent. So H and F would both be right angles according to that. Another thing we know about parallelograms is opposite sides are congruent. So FG is the same as HJ, and GH is the same as FJ. Now, one more thing, we know that if it's a quadrilateral, which it is, that the number of degrees in all angles is 360. And if we add those two together, we get 180. If we subtract that from 360, we get 180. We know that opposite angles in a parallelogram are congruent, so we can just say now that that 180 that we're left with is equal to 2 times J or 2 times G. Let's just call it X. They're both the same. And so if we solve that by dividing both sides by 2, we get that X is equal to 90. So we also know that each of those angles are right angles. So we have 4 right angles, and we have 4 congruent sides. So that makes this parallelogram a square. All right, go ahead and try the next problem. Classifying this as either a rhombus, a rectangle, or a square. Pause if you want to try it on your own. All right, some theorems about rhombuses and rectangles. If a parallelogram is a rhombus, then its diagonals are perpendicular. And if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So what that tells us is these are all right angles here, because its diagonals are perpendicular. And also it tells us that the angles in each of the vertices are bisected by the diagonals. So something like 3 and 4 are the same. So get this. All right, what are the measures of the numbered angles in the rhombus ABCD? So we're going to use those properties we just figured out. Now, because this is a rhombus, AC bisects angle A and angle C. So the measure of angle 2 is equal to the measure of angle 3. We also know that the measure of angle 1 is equal to 100 because a rhombus is also a parallelogram, so opposite sides, opposite angles are congruent. That's from the definition of parallelogram, or a property of parallelogram. And so we now know that the measure of angle 2 plus the measure of angle 3 plus 100 is equal to 180 because it's a parallelogram. And any two consecutive angles in a parallelogram are supplementary. So then we can just subtract 100 from both sides, and we get the measure of angle 2 plus the measure of angle 3 is equal to 80 by the subtraction property of equality. And we can say that 2 times the measure of angle 2 is equal to 80 because the measure of angle 2 and the measure of angle 3 are congruent. And so the measure of angle 2 is equal to 40, which is equal to the measure of angle 3. Okay, theorem 615, if a parallelogram is a rectangle, then its diagonals are congruent. So if RST is a rectangle, then RT is equal to congruent to SU. So let's go ahead and use that here on this rectangle. If MNOP is a rectangle, then we know that PN is equal to OM by that last theorem. And so we can say that 7x minus 8 is equal to 4x plus 10 by substitution. And maybe we'll use subtraction property of equality and subtract 4x from both sides, and then we get 3x minus 8 is equal to 10. Add 8 to both sides, and we get 3x is equal to 18. Divide both sides by 3, and we get x equals 6. And the question asked us to find the length of PN. PN is 7 times x minus 8. And we know x is 6, so we'll substitute that in. And 7 times 6 is 48. 42 minus 8 is 34. All right. Go ahead and try the next one. Pause here if you'd like. Okay, so lesson check. We use the theorem for rhombuses, not rectangles. All right, see you tomorrow.